Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve paper 9709/52 for the session May June 25. Let's start our session with question number 1. Question number 1 says Rachel has three coins. The first coin is biased so that the probability of obtaining a head when it is thrown is one third. The second coin is biased so that the probability of obtaining a head when it is thrown is one fourth. The third coin is fair. Rachel throws the three coins at the same time. The random variable x is the number of tails that she obtains. Draw up the probability distribution table for x. Well, as all the three coins have been thrown together, so let us start writing probability of tail. What are the probability of tail individually? For the first one, probability of tail is one fourth is sorry one third. One third is head, so two third is tail. Two third. And for the second coin, one fourth is head, so three fourth is going to be tail. Three fourth. And the third coin is unbiased, I mean fair, that's why it is going to be half. This is the probability of obtaining tail. Then if probability of h is written, we will write it is one third, one fourth, one third, one fourth, as well as half for the third one. So these are the probabilities independently. Well, now we will have to find when x is equal to p, x equal to 0. Look at this. X equal to 0 means he is not obtaining any tail. After that, p x is equal to 1. Now, first let us complete x equal to 0. Look at this. X equal to 0 means there is no tail at all. That means all of them are heads. So for all heads, it is one third into one fourth into half. And if we simplify, it is going to be 1 over 24. I am leaving them in common fractional form. You can even convert it into decimal fraction. Then when there is only one tail, so for one tail, there are three possible cases. Suppose first one is tail. So for first one, tail from first coin, but rest two may be heads. So those are one fourth and half. 1 over 4 and half. So finally, our this is not all done. So there are two more cases. Suppose second one is tail. So for second one tail, that means first one and third one will be head. So for being head, first one and second one is tail. So that is, for tail it is 3 over 4, and third one is again head, which is half. So this is the second case. What is the third case? Third case is there may be first one and second one, both of them are head. So for first head is one third, one third and half. So one third, and second one is also head. For second head, it is one fourth. One fourth. One fourth. Third one is our tail, which is half. So finally, our probability is going to be equal to, if we simplify, it is going to be 2 plus 3 5, so 6 over 24 means 1 over 4. 1 over 4. Okay, then the third possible case. For third possible case is when there are two tails. x equal to 2 when there are two tails. 2. So what are the possible cases? Let the first two be head. So for first two tail is 2/3 into 3/4, 2/3 into 3/4, and the third one is head. So it is going to be half. Okay, second possible case, there may be first one is head, I mean tail. First one is tail as well as third one is also tail. So second one is head. So second one is 1 over 4, third one is tail. So this is second case, and the third case is, or third case, there may be first one is head but second two are tail. So for second two, 3/4 into half. So finally our probability is going to be 24, then 6 plus 2 8, 8 plus 3 11. It is 11 over 24. 11 over 24. Then when there are three tails, when there are three tails, probability it may be the first, all three are tail. Look, as there are three coins, if we want to obtain three tails, so all of them are having tails, and for tail our probability is 2/3 into 3/4 and half as well. So it is going to be 6 over 24, that means 1 over 6. So these are all possible cases. Now we are going to write probability distribution table. Let me choose a place to write this. Let me write over here under this probability. This is our probability distribution table. Now we are going to insert the values. The first one is 1/24, second one is 1/4, and third one is 11 over 24 and 1 over 6. So let them be written when x is 0, 1, 2 and 3. 2 as well as 3 is the maximum number of tails. So first probability is 1 over 24. If you wish, you can write in decimal also, dividing 1 by 24, but I feel comfort to write in common fraction because both of them are acceptable. Second one is 1 over 4 and third one is 11 over 24, 11 over 24, and fourth one is also 1 over 6. 1 over 6. Sorry, 1 over 4, not 6. It should be 1 over 4. 1 over 4. 1 over 4. So that's all about the solution to question number 1, which is very simple. You can do it yourself. So let's move on to the next question. Question number 2 says, in Milford, 70% of the residents own a bicycle. A random sample of 160 students is selected. Use a suitable approximation to find the probability that more than 120 of these residents own a bicycle. So it's an approximation. Remember, approximation means the distribution is given in binomial distribution and we will have to convert it into normal distribution. So for that, let us write x belongs to binomial distribution, which should be converted to, and the parameters for binomial distributions are n and p. What is the number of total experiment is 160, and individual probability is another parameter is 70%. So it is 0.70 is the probability. Now this is going to be converted to normal distribution. Okay, x belongs to normal distribution, and for the normal distribution we know the parameters are mean as well as variance, and mean is the product of n and p. These two should be multiplied. If we multiply them, it is going to be 112, and the another parameter is Variance is the product of n, p and q. Q is zero point 0.3. If we multiply 112 by zero point 0.3, it is going to be 33.6. 33.6. Well, now we will have to find our probability. Okay, so for probability, let us write probability of x is greater than 120, more than 120, x is greater than 120, equal to, we are going to standardize the score. Z is greater than 120 minus. Now there is the most crucial point of the solution. Look, in binomial distribution they have written 160. Binomial distribution is applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So continuity correction is a must. If we want to find z is more than 120, that means after doing continuity correction it is going to be 120.5. It will be more, not less. Minus our mu is what, 112. 112 over, you know how to find or how to standardize the score. It is square root of the standard deviation. Means standard deviation is the square root of the variance, 33.6. Now if we use our calculator, it is going to be z is greater than 1.466. Well, now we will find the corresponding probability of this z score. Let me draw a figure. Suppose this is our normal curve. Okay, and our z score is 1.466, so definitely it lies on the right side, 1.4. Okay, this. And which part is our probability? We are supposed to find the probability of this dark shaded part, this portion. Okay, and we know that all the probabilities, this probability is definitely less than zero point 0.5. Okay, so what we can do, we will just find whole of the probability, means 1 is the whole probability. From 1 we will subtract the left part. If we subtract left part, we will find our required part. So 1 minus, it is 1 minus probability of z less than, we are going to subtract the left part, 1.466. I think you got my point. We require this dark shaded part, black part. For black part, as it is very tiny, and always the probability given in the probability distribution table is more than zero point 0.5. So how can we find this? We will find the corresponding probability of this z score, the left part, and then we will subtract this left part from 1. So let us go back to our normal distribution table. It is just over here. Our z score is, let me show you, our z score is 1.466. So 1.466 is over here in the row, 1.4 is here, 1.4 is over here, and then 6 column. First column is 6, second column is also 6. This is 6 and another 6 is over here. So which one is our probability? Our probability is going to be over here, this one first, and we will add up, plus we will add up how much, this one, this 8 should be added. So 9279, if it is added, if 8 is added to 9279, it is going to be, let me show you, this is how, and again we will have to add up this final digit. So it is 9287. 9287. Let's go back to our page. That is 1 minus, sorry, equal to 1 minus 0.9287. So finally our approximated value is going to be 0.0173. That's all about this solution, and I think you got my points. Whenever we are given the tiny probability which is less than zero point 0.5, always the probability given in the probability distribution table is more than zero point 0.5. So what we do vice versa, that means reciprocal, because the normal distribution graph is symmetrical. So from whole of the probability, if we subtract the larger part, then we get the smaller part of probability. Let's move on to the next question. Question number 3. Question number 3 says, a bag contains 4 blue marbles and 12 red marbles. One marble is selected at random from the bag. If this marble is blue, it is replaced in the bag, but if it is red, it is not replaced. A second marble is now selected at random from the bag. Find the probability that both marbles selected are the same color. Okay, so let's write our, let me repeat the solution again. So we are to find probability of same color. Okay, same color. So for same color, what are the possible cases? There may be first one blue and second one is also blue, or first one is red as well as second one is also red. So for picking up a first one as blue marble, total there are 4 plus 12 16. So out of 16 there are 4 marbles, so 4 over 16. If the second one is blue, remember whenever a blue is picked up, then it is replaced. That means it's all the same. Again there are 4 blue marbles as well as total 16 marbles. Now it's about red marbles. In the red marbles, if we pick up one red marbles, there are total 12, so it is going to be 12 over 16. And for the second one, remember, if one red marble is picked up, then it is not replaced. So one red marble has been decreased, so there are only 11 red marbles out of not 16. There are only 15 marbles, because already one has been taken away, and remember, it has not red has not been replaced, so it is decreased every time. So finally our probability is going to be 0.6125. If you wish, you can convert it into three significant figures as 0.613. Let's move on to the next question. The next question says, find the probability that the first marble is blue given that the second marble is red. So it's a given, then is the question. For such question, first of all, we'll have to find probability of first one is blue, first blue intersected by second red, second one will be red. Okay, let us find what are the possible cases. Equal to first one, it is first one blue and second one is red. If it happens, suppose for the first one blue, for blue there were 4 marbles, so it is 4 over 16. And second one is, remember, if blue marble is chosen, it is given back, so total number of marbles will remain same. But red, there were 12 red marbles, still there are 12 red marbles. Okay, so probability is going to be, let me write just below this, probability is going to be 0.1875. Now we are going to find the probability of only second one is red. Probability of second red, second R. Okay, so what is the probability for second R? There are two probabilities, possible cases. Look, if second one is R, what about the first one? First one may be blue and second one is R, or first one is R as well as second one is also R. So for probability of blue and red, we have already written here, it was 0.175. Okay, point one, first one is blue. Look at this here. In the previous one here, from the probability is this. Let me zoom it in. Yes, so what are the probabilities of first one blue, second one red is 48 over 48 over 256. 256 plus, if first one is red, then probability is how much? 12 over 16, both of the red. That also we have obtained in the second case, in the previous question. So let me copy from there. First one, if both of them are red, this is our probability. Probability is, so 132 over 240. 132 over 240. 132 over 240. Now using our calculator we can find that 0.7375. Look, this is not our final answer. Our final answer should be, let me write somewhere else here. So our question is probability of first one is red, given that second one is also red. Second one is second red. Okay, equal to probability of first R intersected by second R. Second one is also R, over probability of simply second one is red. Second red. So already we have obtained the supporting information when first one is red intersected by second. First one is blue, sorry, it is not red, it will be blue. It is blue. First one is blue, so for first one is blue intersected by second one red, is this is our probability 0.875. Okay, so we will write this one. This is our probability. So 0.1875 will be divided by, when both of them are red, I mean second red, only second red, it is 0.73. 0.7375. So finally our answer is going to be 0.1875 over 0.7375. It's 0.254. 0.25 as well as 4, which is our final answer. And I can show you whole of the solution at a glance. So let's see what the immediate next question say. The next question is over here. It says vehicles approaching a certain road junction from Bromley must go either left, right, or straight on over time. Over time, it is known that 30% turn left, 25% turn right, and 45% go straight on. The driver of each vehicle chooses a direction independently of all other drivers. Find the probability that the next three vehicles approaching this junction from Bromley all go in different directions. Well, so individual probabilities are zero point 0.3, 0.25 as well as 0.45. So let us write probability of three different directions. Three different directions equal to. So first one, let's say first one goes to left, for which it is 0.3. Second one goes right, it is 0.25, and third one goes straight on, which is 0.45. Now the crucial point, look at this. How can we be sure that the first one is going left? It may happen that first one may go straight, or second one may go left, or third one may go right. As we don't know the specific direction of any of the vehicles, they can be rearranged in many ways. That means 3 factorial ways into, that's why you will have to multiply by 3 factorial. So please don't get confused with this one, as we are not sure that whether first one may be in the third position, third one may be second position, second one may be first position and vice versa. So this way there are total 6 different ways they can interchange their position or directions. So our probability is 0.2025. 2025 is the answer. Let's see the second question. Second one says, find the probability that from the vehicles approaching this junction from Bromley today, the first vehicle to go left is before the ninth vehicle. Since the question includes the word first, look at this is a clue word. If first word is mentioned, that means the question belongs to geometric distribution, because whenever the outcome is found or success is happened, then the experiment is over. So x is our, the word first and until always belongs to geometric distribution, and for geometric distribution our parameter is only the probability. This is about the left. For left our probability was 0.30. Now before ninth vehicle, so it is going to probability of left, before left direction before ninth vehicle. Ninth means it's actually 8 or less than 8. Hence we can write here probability of either 8th vehicle or any vehicle before that. So the formula for this probability of x equal or less than 8 is 1 minus q. Our probability of left is 0.7. So for north left direction is 0.70, which is how many times? 8 times. And the formula is actually probability. The formula is this: probability of x less than or equal to 8 is equal to, not 8, let it be r, okay, equal to 1 minus q raised to r times. Okay, so our q is 0.7. If probability of turning left is 0.3, so probability of not turning to the left is 0.7. So finally our answer is going to be, if we subtract 0.7 raised to 8 from 1, it is 0.942. 0.942. That is what the answer to this part. Let's see what is written in question number 3. Find the probability that from the vehicles approaching this junction from Bromley today, the second vehicle to go left is the seventh vehicle. So let us write with different ink. Probability of second left on second left turn on seventh time or seventh vehicle. Seventh time. So what do we understand from this question? Look at this. On the seventh attempt, it is must that seventh attempt it was nothing but left. So for the seventh attempt, it's confirmed the probabilities for left is 0.3. Now the question of what about the first 6 vehicles? Among the first, it is actually, look at this, it is the second vehicle turning to left. So what about the first one? First one is in among first 6 vehicles. Seventh one is confirmed. Seventh one is sure it is turning to left. So we have written for turning to left the probability is 0.3. But among the first 6 vehicles, we don't know which one is turning left, but there is one vehicle turning left. So out of six only one vehicle is turning left. So this is somewhat a combination formula. So out of 6 only one is turning left, and for turning left probability is 3, and now for turning not to left is 0.7 raised to how many times? 5 times. Okay, so this is actually a combination of binomial as well as simple probability. So if we simplify, it is 3. 6, choose 1 from 6 vehicles. If we choose 1, it is 6 times we can choose, into zero point 0.3 into 0.7 raised to 5. So finally, our answer is going to be 0.00908. If we round it up to 3 significant figure, it is going to be 908. And that is all about the solution to all of these 3 questions. Okay. Yes, I can see you whole of the solution on the same display. Then let's read question number 4. Question number 4 says it's about diagram. No, not question number 4. It is question number 5. It says the times taken T minutes by 300 students to travel to Hollowton College are recorded. The results are summarized in the table below. Time, T minutes, and cumulative frequency. On the grid, draw a cumulative frequency graph to illustrate this information. Let's solve this. Well, this is the cumulative frequency graph. It is not 100% accurate, but I tried my level best to make it as perfect as it is possible. Well, then I kept the video in switched off mode because it took a long time to complete the graph. Yet you can do it yourself. Just let me explain. When it will always start from the lower bound, our lower bound is 0, so at 0 it was 0. Then when it was 10, then onwards always it is upper bound is 10. So at 10 our frequency was 34. Then at 20 our frequency was 86. When our time was 30 seconds, then frequency, I mean cumulative frequency, was 142. Then 208, 265, and 300. You can try it yourself. It's not a big task as all at all. So let's see the next question. The next question says 120 students take more than k minutes. Okay, so we will find 120 students. So 120 students took more than 180 minutes. More than how many k minutes? So let us see how many students take less than k minutes. So 120, the total number of students 300. 300 minus 120 equal to 180 students. So 180 students have taken less than k minutes. So let us find where 180 coincide. Let us say it is 180, maybe it is 150. So 1 2 3 4 5 6 7 8. So just over here, okay, that means 8, no, 1 point above that, over there, over here. So this is the point. Now what will be the number of students, k value of k? Let us see. It is going to be, if I draw, yes, if we can show through this lining, then it is going to be 35 actually, because for 20 30 between 40 and 30, so it is 35 actually. 35 students took more than 180, more than 120, sorry, more than k minutes. So k is 35 minutes. Answer is, hence our k is equal to, hence our k, hence our k is going to be 30. That means, look at this portion, the time, that means this is the time frame. Let me show you from whole of the graph. Okay, this is the time which has been taken by changing the color of ink. This is the time which has been taken by 180 students, and the rest of the time has been taken by 120 students. They have told us to find 120 students. Yes, this portion, this time has been taken by 120 students, and the lower time has been taken by 180 students. So our coinciding point is here, which is 35. That means 35, 120 students took more than 35 minutes. That's why k is equal to 30. Let's see what the next question say. The next question is about calculate estimates of the mean and standard deviation of the times taken to travel to college by 300 students. Okay, we are going to find mean, okay, and as well as standard deviation. So for mean, first of all, we will have to draw the mm, we will have to prepare a frequency distribution table. So let us write first class bound and then frequency, not cumulative frequency. So this is the frequency distribution table. Now in remember, in case of finding mean, your cumulative frequency distribution table will not work. We will have to find the frequency, exact frequency. So let us write the frequency. First frequency was 34. So let us write 34. It is 34. For the second one, you will have to subtract the previous uh, frequency, cumulative frequency. From 86, if we subtract 34, it is going to be 52, 52, 52. Then if we subtract 142 minus 86, which is 56, 56. From that, if we subtract from 208, if we subtract 142, it is 66, 66. Look at this, we are subtracting the previous cumulative frequency from the required one. Then from 265, if 208 is subtracted, then it is 57, 57. And from 300, if we subtract 65, it is 35. Okay, this is frequency distribution table. Now we are going to find the mean. Okay, mean is equal to mean is equal to, so mean is what? Sum of fi xi, that means midpoint of each class multiplied by x value, I mean frequency. So 34 here. How to find the midpoint? If we add up the upper bound and lower bound, and we will divide it by 2. If we divide it by divide 10 by 2, it is 5. Then the frequency distribution is 52. If we multiply it by midpoint is 15. Then midpoint is 56 into midpoint is 25. 30 plus 20, 50. So it is 25. 25 plus the next frequency is 66, which will be multiplied by midpoint, and our midpoint is, what is the midpoint when 66 is our frequency? It is 735 plus our frequency is 57. 57 will be multiplied by 40, it's 50. It will be 50. Then the final frequency is 35, which will be multiplied by midpoint 150, that is 75. 75, that's all. And total number of students is 300. So let us write here 300. 300. Okay. So using our calculator, we get that our mean is 33.8. So this is one of the answers. Now they have told us to find the standard deviation also. So for standard deviation, if we write here standard deviation is equal to, square root of ex squared. Okay. Or should I show this I think I can do it directly. Okay, so it is going to be, sorry, here it is not 330, it is going to be 300. Okay, now this is actually standard deviation is what? Sum of x square. I think I should show you what is the formula. The formula is square root over sum of fi x squared minus sum of fi xi whole, that is mean. It is actually mean. So this is the formula for standard deviation. Now we are going to apply this concept, for which we will have to find sum of fi x square. Sum of fi x square means frequency will remain same, only x will be squared. So it is 34 into 5 square plus 52 into 15 square, 15 squared. Then third frequency is 56 into 25 square, 25 square. Then next frequency is 66, 66 into x square, x is 35, so 35 square. After that, the next frequency is, I don't have space to write this, so what I can do, then 66 into 35 square, 66 into 35 squared plus 57 into 50 square, 57 into 50 squared plus the final one plus final frequency is 35, so 35 into 75 square, 75 square. Okay, then minus our mean value has already been obtained. It is minus, what was our mean value? Mean value was 33.8 whole square, and here in the formula I think I skipped something. It is over n, sum of f. Here in the formula here we will have to write over sum of sum of fi. Okay, so sum of fi is how much is total number of student, total frequency is what? Our total frequency is 300, because total number of student is 300. So let us write here 300. Then if we use our calculator, it will show that 20.4. 20.4. Before we end up, we will have to check whether we have written all of them or not. Total there are 1 class, 1 2 3 4 5 6. So 1 2, let me count, 1 2 3 4 5 as well as 6. Yes, we have written all of them. So this is what the standard deviation. Standard deviation is the square root of variance. Let's see the next question. The next question is question number 6. Question number 6 is, yes, so question number 6 says, find the number of different ways in which the 10 letters in the word amalgamate can be arranged so that there is an M at the beginning and M at the end and no S are together. We are aware that for arrangement we apply the concept of permutation. So let us write the scenario of this case. So first one should be M. First one is M, then 1 2 3 4 5, then total there are 10 letters. Among 10 there are 4 A's. Okay, there are 4 A's. 1 2 3 4, there are 4 A's. So if A's are left, there remains 6 digits. So 1 2 3 4 5 another one is 6. So how many digits are left here? There is 1 2 3 4, 1 2 3 4. So these four digits can interchange their position, and we have already decided that we are going to apply the permutation concept for arrangements. So let's write number of arrangements arrangements is equal to, there are four letters which can interchange their position in 4 factorial ways. So it's 4 factorial ways. Now about a, they told that a's cannot be together. That means the a may be over here. Suppose a can be over here or there or in this space, in this gap, or it can be over here. So how many places or position are left for a? There are total 1 2 3 4 5. So there are 5 positions left for a is going to occupy this 5 space, but out of 5 they have only, there are only 4 a's, so they will occupy 4 out of 5 places. They will occupy 4, and in between them there will be multiplication symbol. So if we simplify 4 factorial into, and there is one more concept we are going to apply is, look at this, as all of these 4 a's are identical. For identical letters always we will divide by the same number of factorial. There are 4 identical a's, that's why it should be divided by 4. Now 4 factorial into 5 factorial, these 4 factorial and this 4 factorial can dissolve each other. So if they go away, there will remain only 5 fact 5p4. So if we simplify, it is 5 factorial over 5 minus 4, that is 1 factorial. 5 factorial means 120, and if we divide by 1, it is 120. So number of arrangements with this restriction is 120. Well, then the next question says find the number of different ways in which these 10 letters in the word amalgamate can be arranged with exactly 3 letters between the two m's. Okay, there will be 3 letters between the m's. So first one is 1 2 3 4 5 6 7 8 9 as well as 10. So first one is going to be m, and between the m's there will be 3 letters, so fourth one is also m. Now how many are left there? If 2 m's go away, there remains 8 more letters. Okay, so the number of arrangements is equal to, total there are 8 letters left. They can be arranged in 8 factorial ways, and among these 8 letters there are 4 a's, so we will have to divide by 4 factorial into look at this, this m is, let me show you, this m can be over here or there or there or there or there. So is this m will be over here or there or here. That means how many possibilities of changing the position of this m? So 1 2 3 4 5. So there are, sorry, not 5, it will be 6. It may be over here also. So there will be 6. Let me count once again. It is already 1 2 3 4 5 6. So there are 6 possible cases for m's to change their position. That's why it will be multiplied by 6. If we multiply it by 6, it is going to be 8 factorial over 4 factorial into 6, that is 10080. I think you have understood this simplest concept, that first there are 8 letters left, all of them will have to be arranged in 8 factorial way. After that 8 factorial way, 8 letters contain 4 identical a's, that's why it has been divided by 4 factorial. Then this m also can change their position in 6 different ways, that's why it has been multiplied by 6. The next question says 5 letters are selected from 10 letters in the word amalgamate. Find the number of different selections in which the 5 letters include at least one M and at least two A's. Okay. So, first of all, we will write the scenarios. There are 4 A's. Okay. 4 A's, 4 A's, and 2 M's. 2 M's. So among 4, they have told minimum there will be 2 A's, at least 2 A's, and 4 and 2, 6. Then there are 6 other letters, 6 others. Well, so the first case, if there are 2 A's, if we take 2 A's, and then minimum we'll have to take 1 M. If we take 3, there remains only 2. 2 letters will be chosen from the rest 4. It should not be 6, it should be 4. Yes, it's 4 others letter. Then the second case is, if we choose 2 A's, then we can choose 2 M's. Then there remains only 1 letters to be chosen from the remaining 4 letters. Then if we choose 3 letters, suppose 3 A's and 1 M's, 1 M, so 4 goes, there remains only 1. After that, if we choose again 3 M's, 3 A's and 2 M's, so 3 to 5, there is no letter to be chosen from the remaining ones. Then the fifth case, if we choose 4, because we can choose maximum 4 A's and minimum we can choose 1 M, and then there is no other letter to be chosen from the others. So let us write this scenario. If we calculate this, now from 4 A's, if we choose 2 A's, then there is number of choices actually 1. So it's a concept, please don't get confused. Remember, the combination formula is a combination concept is applicable for distinguished and distinct objects. Here all 4 A's are identical. So if we pick up 2 A's, it will not be different from the other 2 A's. So is for m's. If we pick up one m from two m's, it's all the same actually. So remember, in case of combination for identical objects, the combination is always 1. Okay, so there is no necessity of writing these two, but these 4 letters, the final case, 4 remaining letters are distinct and exceptional to each other. That's why you will have to choose this. So if we choose from 4, if we choose 2, it is going to be 4 choose 2 means 4 factorial over 4 factorial over 2 factorial and 2 factorial. 4 factorial means 24 and 2 factorial 2 4, so it is going to be 6. That is 6. Let us write here 6 equal to 6. So for the first case it is 6. In the second case, as A's and M's are identical, so their number of selection will be 1. And from 4 remaining letters, if we choose 1, from 4 if we choose 1, then there are 4 different ways. If we choose 1 from 4, it is actually 4. there are 4 ways to select one letters from 4. Then the third case is also we are choosing 4 from 4, we are choosing 1, so it is also 4. And in the next two cases we are not choosing any letter, so it is 404C0. From 4 letters we are choosing nothing, so that is only one way. If we choose nothing from 4 letters, then there is one way. And for the final one also, from 4 if we choose 0, it is 1. So number of selections we can write here, number of selections. Hence number of selections, so number of selections is going to be, if we add up 6, 4, 10, 14, 16. So total number of selection is going to be 16. So what have we learned from this solution? We have learned that for identical letters, the number of total choice or ways of choosing different letters is 1. For identical, as there is no difference among the objects, so there is only one way to choose the identical letters. That's why they have been ignored. These first two cases have been ignored. Okay, these first two cases, because there is only one way in each case. That's why it has been ignored, and rest of them have been calculated. So total we have got 16. There are 16 ways to choose these numbers, these letters according to this restriction. Let's see the next question. The next question is the last of all questions of this paper, which says kestrels are birds whose adult wingspans are normally distributed with mean 74.8 centimeter and standard deviation 3.2 centimeter. A random of sample 120 adult kestrels is selected. How many of these 120 adult kestrels would you expect to have wingspan between 72.4 centimeter and 76.3 centimeter? So this is actually expectation. Okay, for expected value is actually product of mean as well as total number of sample. Total there are 120 adult kestrels. So first of all, we'll have to find mean or probability. Okay, so let us find the of probability of what, x 72 until 74. This is actually a binomial expansion. Since this is a normal distribution, let us write the parameters. X belongs to normal distribution and the parameters are mean as well as variance. Mean is 74.8 and variance is square of standard deviation. Squared of standard deviation is 3.2. So this is the variance. Okay. Then they have told us to find the probability for expected value. We should know the probability. X is not x, it is actually range is given. So from between 72.4 and 76.3. So 72.4 until 76.3. 76.3. Then we will have to standardize the score. If we standardize the score, we know that is x minus mean is 74.8 over standard deviation, which is 3.2. Then z, again it is 76.3 minus mean. 76.3 minus mean is 74.8. 74.8 over standard deviation is 3.2. Using calculator, we can write our first z score is negative 0.75. Negative 0.75 less than z, and less than the second z score is 0.469. 0.469. Well, so we'll have to find the probability when z score is ranging from negative 0.75 until 0.469. Let me show you this from a graph. Let me draw the graph over here. Okay, So this is our graph, and here our z scores are negative zero point 0.7. Suppose negative zero point 0.7 is over here, negative zero point 0.7, and another z score is positive 0.469. 0.469. Let it be. So which one is our probability? Our probability is dark shaded region. Dark shaded region. So this dark shaded region is our probability. So how can we find this probability? Let me draw another curve. From here, if we, yes, we require this part. So from whole of this, look at this, from here, if we take from the same graph also I can show, but yet I am drawing another one. So the easy step we can follow is, look at this, if we find whole of this, the probability of whole of this when z score is zero point 0.7, from whole of this, if we just subtract that blue part, if we just subtract this blue part, then we will get our required the dark shaded region as probability. So what we will do, we will just subtract, it is probability of z less than 0.469. From this probability, if we subtract probability of z less than negative 0.75, we will get our shaded region according to this. You can have the shaded region as well. So what we are going to do, we are going to find the second values of probability of z less than 0.469, 0.46969 minus. Now for this shaded region, what we can do, I will have to draw one more figure. Let me draw a figure. Look at the second figure. This blue shaded region should be subtracted. Okay, if we want to subtract this blue shaded region, this is when the z score is 0.75. So what can we do from whole of the probability? I mean, from 1, if we subtract 1, then if we subtract this portion, I mean left side, when probability z is less than 0.75, 0.75, if we subtract this part, I think you got my point. If we subtract this left part from whole of the probability, whole probability means always 1. So from 1, if we subtract the left part, we will get this tiny blue shaded part, which is required to be obtained. Then it becomes probability of z less than z less than 0.469 minus 1 plus probability when z score is less than 0.75. Now using our normal distribution table, we are going to find that our final probability. So it is going to be equal to, now let us see how much is the corresponding probability when z score is 0.469. Okay, our first z score was 0.469, so zero point 0.4 is over here, and then 6, 0.4 and 6 is over here, then there is 9, the final one. So our column is this one, simply this is 0.6772, to which we will add up 32. If we add up 32, it is going to be 0.6804. So one is 0.6804. Then the second z score was our 0.775. So let us see for 0.75. 0.7 is over here, 0.7 is over here, and 5 is over here. That means this is our probability from 0.7734. Here, let me erase this. First probability was 0.60, sorry, 0.6804, 0.6804 for the first one. Then the second one was 0.75. So zero point 0.7 is over here. Sorry, zero point 0.7, and that is 5 is over here. So it is 0.7704, not 0.7704, it is 0.7734. This is our probability, 0.7734. So these two are our probabilities. Let us insert these values. The first one is 0.6804, second one is 0.7734. Let us go back to our page. So the first one is, the first probability was 0.6804, 0.6804, then minus 1 plus the third one is 0.7734, 0.773 as well as 4. If we use our calculator, we will get 0.4538, 0.4538. Remember, they didn't tell us to find the probability. They have told, the question has told us to find what? It is written here to find the expected value. So expected value is probability into total number of experiments. How many birds have been taken as sample? 120. So we will write our expected value is 120 into probability. Into probability is point 0.4538. So finally our expected value is going to be what? If we multiply, the product is going to be 54.5. So we can write here 55 birds. 55 birds. 54.5 means it's more than 54 birds, so it's better we write 55 birds. That is the answer to the question of expected value. Okay, after that we will solve the next one. The masses of adult kestrels are normally distributed with mean mu kg and standard deviation as sigma kg. It is known that 20% of the adult kestrels have mass greater than 0.202 kg, and 25%, 25 or 20, 28% have mass less than 0.185 kg. Find the value of mu and the value of sigma. So this is a different normal distribution. Let us write y belongs to normal distribution, and the parameters are mean is mu and standard deviation is sigma, so variance is sigma square. Our parameters are mean as well as sigma square. Now they have told us to find y probability of y is greater than, look at this, greater than 0.202 kg, and probability is 20%. So greater than 0.202, 202 is probability of masses more than 0.202 kg is 0.20, that means 20% is the probability. Well, if we standardize the score, z is greater than 0.202 minus our mean value over standard deviation, which is sigma, equal to 0.20. Okay, or probability of z less than, Yes, now for the probability of 0.20, we will have to find corresponding z score. And look at this, 0.20 is the tiny part in the graph. If I show you from the graph, look at this. This is your graph. Okay, let me choose different thing. Suppose this is your graph. So from this graph, it is 0.2% and right side of the z score. Suppose here your z score is over here, so it's tiny part. Okay, this part, this part is your probability, but none of the probability given in the probability distribution table is less than zero point 0.5. It's always more than zero point 0.5. So actually what we will do, we will find z score is this one. It is 2.2. Suppose it is 0.202, 0.202. Okay, well, for this, actually z score is this, and we are going to find the greater probability. Remember, the less than zero point 0.5, if the probability is less than zero point 0.5 and there is no z score given there, so all the probabilities are more than zero point 0.5. As z score is same and we have already fixed the position of z score on positive side because it is positive, um, because the probability is lying on the right side and it's very tiny. So what we will do, we will find the probability of z score of corresponding probability of 8. Let's go back to that page. Yes, from here we will find when the probability is z score, when the probability is 8. Okay, let us see where 8 lies in. We require 8. Let me erase the unnecessary parts. We may not find exact probability, but we can calculate this. Look at this, this is our probability we require 0.80, so 0.7995, to which we can add this 5. So what is our corresponding z score? Our corresponding z score is zero point 0.8 as well as zero point 0.4 as well as zero point 0.2. So our corresponding z score is 0.842. So let us write this 0.842. Over here we will write our z score when the probability is 8. Our z score is 0.8, 0.842, 842, when the probability is 0.20. Now, if we compare this coefficient, it is going to be point, hence, not hence, let us write directly. So 0.202 minus mu over sigma is equal to 0.842, because probability is same in both cases. If we isolate sigma, sigma is equal to 0.202 minus mu over 0.842. We may leave this as equation 1 because there will be two simultaneous equations since two values are to be obtained. This is the first case. Now let us choose some space so that we can write the final case. So for the final one, we can write here again. It is, we can write here again. Again, probability of y less than or greater than. Let us see. The second scenario is 28%. Let me change the ink. 28% of the birds have masses less than. This is less than 0.185 kg. 0.185 kg. So we will just substitute these values. Let me change the ink. Probability of y less than how much? 0.185. 0.185 kg probability has been given as 28%, means 0.28. 0.28. Okay, So if we standardize this score, it is going to be probability of z less than 0.185 minus mean, and our standard deviation is sigma equal to 0.28. I think you remember in the previous case I have told that how to find the z score of. Again we are drawing another figure. From this figure, look at this. If this is our figure with different ink, this is our figure, and we require which percent less than. So as that, this is our, let me draw again. So our probability is this tiny red black shaded part. This part is our probability. Okay, so for this one, our one thing is very sure, our z score is lying on the left side to o from the origin. So if it the z score lies on the left side, it must be negative. Okay, so for negative z score, now we are going to find the corresponding z score when probability is 28. So instead of 28, we will find 72, right? But always we will look for the greater probability. Remember, if we find for z score, always we will find the greater probability. Probability z score for probability 70.72 and z score for 0.28 are exactly same. Just the position is positive and negative, left side and right side. If we swipe it to the right side, it will be exactly same. Probability will remain same, but there will be change in the symbol. We have already decided that it is our probability z score is lying on the left side, so it is negative. So negative, now we will have to find how much is the corresponding z score when probability is 0.28 or 0.72. Let us go back to that page. 0.72 is our probability. Let us see where 0.72 is. 0.72 is our probability. For 0.72, we will have to find here yes, this one. Look at this. This is 0.7190, and with these, if we add up this 10, it is going to be 72. So for 0.72, our column is 5, sorry, our row is 5, column is 8. So 0.58, another column is 3. So 0.583 is our corresponding z score for this probability. 0.583, our z score is 0.583. 0.583 negative, because the probability, the region is the tiny part. 0.583 is equal to 0.28. Now if we compare the z score, it is going to be 0.185 minus mu over standard deviation is equal to negative 0.583. We may leave this as equation number 2. So on in both of the equations, left side is, look at this, sigma, and right side are different, so definitely right side will also be equal. So from equation 1 and 2, from equation 1 and 2, from equation 1 and 2, let me change the color. From equation 1 and 2, 2 and 1, whatever you write, 1 and 2, 1 and 2. So the left side of equation 1 was, let us write the second equation. 0.185 minus mu over sigma is equal to, sigma is the, sorry, we will have to write this. Equation 2 has not been formed well. Let us form the equation 2 well. If we make sigma as subject, it is going to be sigma is equal to 0.185 minus mu over negative 0.583. If we dissolve the symbols, then sigma is going to be mu minus 0.185 over 0.58 as well as 3. This is our two equations. So at a glance we can see both the equations. These are the two equations. Now from equation 1 and 2, I will have to write somewhere else. Let's take a new page. So we will write here from equation 1 and 2. From equation 1 and 2. From from equation 2 and 1, or 1 and 2, whatever you write, 2 and 1. Okay, now we are going to see what was our equation 1. Our equation 2 was mu minus 0.185 over 0.583, which is equal to mu minus 0.202 minus mu over 0.842. Then if we do cross multiplication, we will get here 0.842 mu into 0.842 into um, sorry, it is minus, not mu, it is going to be minus symbol. Mu minus 0.85, 0.842 into 0.185 equal to it is going to be point, how much was the denominator? The denominator 0.583. So 0.583 into 0.583 into 0.202202 in minus point minus 0.583 mu. Well, after that, if we simplify this, let us make mu as subject. So it is going to be mu minus mu. So 0.842 mu, 0.842 mu plus 0.583 mu is equal to 0.583 into 0.202 plus plus 0.842 into 0.842 into 0.185. Then if we make mu as subject, mu is going to be, or mu is equal to 0.842 plus 0.583, and the numerator is 0.583 into 0.202202 plus 0.480, 0.842 into 0.185. Hence our mu is going to be, using calculator we get that our mu is 0.192. Hence our sigma is going to be, sigma is equal to, any of the equation can be picked up. The second equation was mu minus, mu is 0.192 minus here, hence minus 0.185 over 0.583, which is equal to 0.192 minus 0.185. No, if we use the rounded figure, we will not get exact value. So let us write some more well digits after this. It was actually, let me show you. It was It was 0.1919, 0.191955955. So we will try to write this exact value. It is going to be, your answer will be up to three significant figures. It is your answer. But when we use this information, we'll have to write as much as possible for more accurate answer. Let us write 0.19195 minus our, it was 0.185, 0.185. Then you will get the most exact number, which is 0.00119. This is our standard deviation. So that's all about the solution to question number 7b. Okay, this is the first part of the solution, and the final part of the solution is over here. Our mean is 1.191, 0.192 if we round it up to three significant figures, and our standard deviation is 0.0119. Let's move on to the final part of this question. This part says 10 adults kestrels are selected at random. Find the probability that fewer than 3 have masses greater than 0.202. So as the total number of experiments is given, this is definitely a binomial distribution. So our x belongs to binomial distribution. And the parameters for binomial distributions are n and p. N is 10, and probability for, let us see what was the probability when the masses was greater than 0.202. Mass was 0.202. When mass was greater than 0.202, look at this, this is our probability. When mass is point greater than 0.202, our probability is 28%, that is 0.28. So our probability is here 0.28, 0.28. Now already we have decided that this is a binomial distribution. So probability of, they have told us to find the probability that fewer than 3. Fewer than 3 means x is less than or equal to 2. Okay. Less than 3 means it will be maximum 2. So for maximum 2, there may be no kestrel which is whose mass is greater than 0.202. There may be no kestrels, or there may be only one kestrel, or there may be maximum two kestrels. Now we will find these probability. Okay, so when x is 0, this total number of, it is combination formula, 10 choose 0, that is no one is having mass greater than 0.20. So probability is 0.28. 0.28 is no one, so all of them are actually less than, mass is less than 0.202, whose probability is 0.72 raised to 10. If there is only one bird having mass less than, greater than 0.202, so 10 choose 1, one bird has the probability of zero point 0.2, and rest 9 is less than this probability. So 0.7 to how many birds? 9 birds. Or there may be 2 birds. There may be 2 birds. So out of 10, 10 choose 2, and 2 birds is, 2 birds are having the mass greater than, so 2 8, 2 birds, and rest 8 birds are having the mass less than 0.202. So it is 0.72, 0.72. How many birds? 8 birds. 10 choose 0 means actually it is 1. Only there is one way we can choose nothing from 10. And so this is going to be simply point. So it is going to be 0.72. How many times? 0.72 raised 10 raised to 10. And from 10 birds, if we choose one, there are 10 ways we can choose them. This 0.28, 0.28 raised to ones. Is it 0.28 or 20%? Let us go back to the question. Is it 0.2 or 0.28? It is greater than 0.28. Sorry, we made a mistake actually. it is it is actually 20%. Sorry, it should be 20% of the adults have the mass greater than zero point 0.2. So instead of 28 it will be 0.20. It should not be 28, it should be 0.20. Sorry, in probability we made a mistake. It should be 0.20, not 28. So wherever there is 28 we will write 0.2020. This is also 0.20. Everywhere let us write 0.20. These are 0.20. This is also 0.20. Then this is, if this is 0.20, so having the probability of having mass less than 0.202 will be 80. So this is going to be 80. This is 80. 80. This is also 80. 80. And let's make change to the next one. This is also 0.80. 80. Okay, so it is 10 into 0.20. Then for the third one it is 10 factorial. 10 into 9 into 8 factorial over 2 into 8 factorial. Okay, then it is going to be 0.202 times and 0.808 times. 0.808 times. If we calculate, use our calculator, it is going to be 45. Okay, so zero point 0.7, not 72, it is actually 80. 80 raised to 10 times. So 0.80 10 times into this, using our calculator we are going to get 0.11. So the calculator shows as 0.678 as the final probability. So this is the probability when the masses of less than 3 birds have 2.202 kg. That's all about the solution to the final part of this question. And if I show you the previous part, A and B, A and B is, here is B, then this is A. So let me show the final page once again. Let me zoom it out. Yes, this is the final page. So thank you all for watching the video, and may Allah bless all of us with beneficial and heavenly knowledge. And if you think that the channel is worthy of being subscribed, then please do the needful. Fi amanillah.